Welcome to This Explainer. Today, we're diving deep into the 2026 Practitioner's Toolkit for AI Image Generation. Look, if you've ever been totally frustrated by the unpredictable, kind of chaotic nature of generative models, you're absolutely in the right place. We're going to break down exactly how top agencies are taking these clumsy base models and transforming them into highly controllable, totally production-ready pipelines. We've got a really great roadmap for today. We'll kick things off with the fundamental problem with text, and then move through the three absolute pillars of modern image control: ControlNet, LoRA, and IP adapter. After that, we'll put it all together in the modern pipeline and wrap up with some crucial pro tips and pitfalls. Let's get into it. Section 1, the problem with text. Okay, let's just go ahead and shatter the illusion right now that text alone is enough of a control signal for generating truly professional images. The core issue here is honestly staggering when you break it down. Text literally only pins down about 10% of what you actually need to specify to create a precise image. That leaves a massive 90% of the visual info, stuff like lighting, the exact layout, the specific camera angle, completely up to unpredictable chance. The reality is most of what makes an image great is purely visual, and frankly, you just can't describe it efficiently in words. For example, take a standard prompt like a woman in a red dress walking a dog on a busy street. Sounds descriptive enough, right? Well, not really. This gives the model absolutely zero information about where the dog is actually standing, what exact pose the woman is striking, or the specific perspective of that busy street. Now, you might be thinking, well, let's just train the model to understand all those specific signals. But retraining a massive 2.6 billion parameter model like SDXL from scratch for every single spatial layout like pose or depth is just financially ruinous. It's completely impractical. So the crucial takeaway here is that we need a lightweight sidecar approach to handle spatial structure without ever touching the base model itself. And that brings us to Section 2, ControlNet, controlling the space. ControlNet is exactly how we rein in the space, and the process is incredibly elegant. First, you take a pre-trained model and you clone the encoder half of its unit, the core engine that generates the image. Second, you completely freeze the original massive backbone so it doesn't lose any of its vast knowledge. Third, you feed your extra inputs like depth maps, edge detection, or maybe pose skeletons into that newly cloned side network and connect it back to the original model. Just to put that into perspective, for SDXL, this little side network is only about 360 megabytes, which is tiny compared to the massive base model.
But the real genius that makes this all work is a mechanism called zero-convolution. You're probably wondering, if we just slap a random new network onto a fully trained model, won't it just output garbage and ruin everything? Well, by initializing these one-by-one connections to 0, it basically behaves exactly as an identity function at step 0, meaning it does absolutely zero harm to the frozen base model before it learns the new signals. It just smoothly and slowly ramps up its influence over time.
Okay, so ControlNet gives us our spatial control, but what about style? What about the subject? That leads us right into Section 3, LoRA, teaching new concepts. We need a way to teach the model new things without the massive compute cost of a full Dreambooth fine-tune. Instead of doing a full fine-tune that changes every single parameter, which, let's face it, is an incredibly heavy and expensive calculation, LoRA works a bit of mathematical magic. It freezes those massive linear layers and just adds what's called a low-rank delta. Basically, you take the original weight, W, and add a new, much smaller matrix calculation. The rank, or R, is basically your tuning knob, and it's fundamentally way smaller than the original dimension, D. A standard rank for attention layers is usually just around 4 to 16. By compressing the update this way, the numbers become just staggering. LoRA yields an astonishing 20-fold reduction in parameters. Seriously, if you look at SDXL attention layers, instead of training 410,000 parameters, you are only training about 20,000 parameters per adapter. You get the exact same conceptual learning, but with a tiny, tiny fraction of the computational horsepower. And for you as a practitioner, the everyday benefit here is a total game changer. Instead of having to download and store a massive 5 gigabyte base model for every single art style, character, or brand aesthetic you might want to use, your semantic updates are packaged neatly into a tiny 20 to 200 megabyte file. It makes your entire workflow completely modular. But hey, what if absolutely no text can describe the exact visual aesthetic or mood you're going for? Enter Section 4, IP Adapter, Image as Prompt. This is exactly where the IP adapter shines. It literally treats an image as a prompt. It uses the clip image encoder, which you can think of as a translator between visuals and text, to turn a reference image into tokens. Then it injects those tokens directly into the model's cross-attention layers right alongside your standard text tokens. It basically lets you say to the model, hey, generate an image exactly in the style of this specific reference image, all without ever needing to train a new LoRA. It's brilliant. So now we've got all the pieces on the table. Section 5, building the modern pipeline. And listen, this isn't just theory anymore. This is the exact standard practice shipping at every top agency in 2026. Think of this as your ultimate practitioner's cheat sheet. You use Dreambooth when you absolutely need strong, unshakable identities, even with the heavy compute cost. You drop in an IP adapter when you've got a reference style that words just simply can't capture. You layer on a LoRA for personalized semantic concepts, like maybe your brand-specific art style. And finally, you use ControlNet when you need exact spatial layouts, like a specific character pose or a precise depth-aware composition. So if you take away one crucial point from this entire explainer, let it be this division of labor. ControlNet acts as your spatial sidecar, LoRA as your semantic sidecar. Modern production pipelines don't just pick one of these, they stack them. It is incredibly common right now to see an architecture featuring a frozen SDXL, SD3, or Flux-based model with maybe 2 to 5 LoRAs layered on top for style, 1 to 3 ControlNets locked in for layout, and an IP adapter thrown in for that final visual nuance. It's all about stacking.
Now, setting all this up sounds amazing, but things absolutely can and do go wrong in the real world. Section 6, Pro Tips and Pitfalls.
First up, do not overscale your LoRAs. The alpha multiplier is basically your strength knob, dictating how strongly the LoRA affects the image. Pushing it to 2 or 3 is a common rookie hack that just results in these deep-fried, completely broken outputs. Keep that alpha under 1.5. Second, if you're stacking multiple control nets, like say a pose and a depth map, make sure their combined weights sum to roughly 1.0. Otherwise, the image overshoots into total chaos. And third, always double-check that your LoRA matches your base model architecture. An SDXL LoRA will silently fail on an SD 1.5 base because the attention dimensions just straight up do not match. Furthermore, if you happen to be running a SaaS or a large-scale pipeline, these next tips are absolute gold. Hot swap your LoRAs dynamically per request instead of baking them into the base model weights. Merging them might give you a tiny little speed boost, but it totally destroys your ability to scale the alpha at runtime, and it completely ruins multi-tenancy, which is your ability to serve multiple unique users efficiently. Next, remember that each ControlNet acts as an extra attention lane, so budget for about 1.5 times the inference compute cost per active ControlNet. And finally, leverage quantized LoRAs. You can neatly stack multiple LoRAs onto a 4-bit or 8-bit quantized base model, like a 4-bit flux base, to dramatically save VRAM without blowing out your memory limits.
And there you have it. You now understand the true underlying mechanisms of ControlNet for space, LoRA for semantics, and IP adapters for visual prompting. But way more importantly, you know how to combine them safely and efficiently like a true pro. The tools to perfectly control AI imagery are sitting right in front of you. So the only question left really is, what are you going to build with it? Thanks so much for joining me on this explainer, and I'll catch you in the next one.